If a weightlifter doubles their food intake for a week, how exactly does that translate to the pounds on the bar? Or if a tech company upgrades to a faster processor, how exactly does that drive up the retail price of the laptop? And the ultimate question for any business owner, if you open a brand new location, what exact dollar amount will you make in your first quarter? We collect mountains of historical spreadsheet data trying to find the answers to these questions. But to the human eye, raw numbers scattered across rows and columns just look like chaotic noise. To make sense of it, statisticians use a tool called Simple Linear Regression Analysis. It operates as the statistical engine driving modern business and science. This chart sets up the basic framework. We take a factor we already know, called the independent variable on the x-axis, and use it to mathematically predict the outcome we want to know, the dependent variable on the y-axis. By isolating that mathematical relationship, linear regression replaces guesswork with a calculated forecast based on the weight of historical data. Let's test this with a real case study. Mr. Pizza runs a chain of local restaurants in the Colonia area and wants to expand his operation. He operates on a specific business theory. Restaurant locations situated near larger university student populations naturally yield higher quarterly sales. To test if this is mathematically accurate, he pulls the historical performance data from 10 of his existing restaurant locations. This scatter plot charts his historical results. You can see the extremes. A location near a tiny campus of 2,000 students generated 58,000 rupees in quarterly sales. Meanwhile, a location near a massive campus of 26,000 students pulled in 202,000 rupees. You can see an obvious upward slope, but the dots still form a messy, imprecise cloud. We can't look at this scattering and point to a specific, guaranteed future sales number. The raw data proves a trend exists, but businesses require a precise formula to actually make a secure financial decision. This is where we apply a concept called the least squares method. It allows us to cut straight through the visual chaos of that scatterplot. The method calculates a single, perfect straight line through the center of the data. It's positioned precisely so that it minimizes the total vertical distance between the line itself and every single dot on the graph. For our pizza business, that perfect line generates an exact algebraic equation, y equals 60 plus 5x. Let's break that down. The 60 is the intercept. It dictates that if a restaurant had exactly 0 local university students, its baseline quarterly sales would still be 60,000 rupees. The 5 is the slope. This tells us that for every additional 1,000 students in the local population, the quarterly sales will increase by an average of 5,000 rupees. That simple two-part equation is the engine that converts a messy historical trend into a strict, workable mathematical rule. Now Mr. Pizza faces a high-stakes decision. He has found a new real estate location situated right next to a campus with exactly 16,000 students. We run the calculation by plugging the number 16 into our established equation. That gives us 60 plus 5 times 16. The math gives us a definitive prediction. We can expect this specific location to generate an estimate of exactly 140,000 rupees in quarterly sales. But before signing a commercial lease, we have to ask a vital risk assessment question. How much trust can we actually place in this single prediction? To find out, statisticians calculate the Pearson correlation coefficient, often just called R. It serves as the ultimate reality check for measuring the strength of the relationship between two variables. If we run the correlation formula on our pizza restaurant dataset, we get an R value of 0.9501. In statistics, a perfect correlation is exactly 1.0. Because our score of 0.9501 sits so close to 1, it proves that the actual data points rest extremely tight against the trend line, making our prediction highly reliable. This exact framework goes far beyond local retail. Whether you are a researcher analyzing medical data to track fetal growth, or an analyst pricing a massive tech company's initial public offering, mastering this formula provides a significant professional advantage. Simple linear regression doesn't eliminate risk, but it does eliminate the need for blind guesses, providing a clear, mathematical estimate for what's likely to happen next.